Good morning, students. Today, let's learn about interconversion of states of matter and the law of conservation of mass. Interconversion of states of matter. From the diagram, it is clear that interconversion of matter is the change of matter from one state to another and back to its original state. We can see that solid is converted into liquid, liquid is converted into gas, and vice versa. How can we convert one state of matter into another? Do you know? By changing the temperature and pressure, we can convert one state of matter into another. For example, water can be turned into ice by cooling, and we can convert water into steam by heating. During the process of interconversion of matter, there is no change in mass or composition of the substance. Only the state of substance is changing. The change of a substance from solid state to its liquid state at a particular temperature is called melting. Fusion is the another term used to refer melting. In melting, we can convert a solid into liquid by heating the solid up to a specific temperature called melting point. Every substance have a definite melting point. We can define melting point as the temperature at which a solid substance changes into its liquid state at 1 atmospheric pressure. For example, the melting point of ice is 0 degrees Celsius, which means at 0 degrees Celsius, ice get converted into water. The melting point of tin is 231 degrees Celsius. Every substance have a definite melting point. Freezing. Freezing is the reverse of melting. What is freezing? In melting, a solid is converted into liquid. As freezing is the reverse of melting, what happens in freezing? In freezing, a liquid gets converted into solid. When a liquid gets converted into solid, on cooling, a liquid gets converted into corresponding solid, and this process is called freezing. Solidification is the another term used to refer freezing. We know melting occurred at a definite temperature. Like that, freezing also occurred at a definite temperature, and this definite temperature is called the freezing point. Evaporation. It is the change of a substance from liquid state to gaseous state at room temperature or any other temperature below its boiling point. Evaporation is also known as vaporization, and it may occur at any temperature. There is no particular temperature for evaporation. It occurs at any temperature below the boiling point of that liquid. Now, let's see the factors that affect the rate of evaporation. Temperature, humidity, and wind are the factors that affect evaporation. What is the effect of temperature on evaporation? As the temperature increases, the rate of evaporation also increases. For example, clothes dry sooner in summers than in winters because of high temperature in summer. What is the effect of humidity on evaporation? Humidity is the amount of water vapor present in atmosphere. If the humidity in the atmosphere is high, then the rate of evaporation is low. Now, what is the effect of wind on evaporation? Rate of evaporation is higher with the strong winds because as the water gets evaporated, water vapors come to the surface. The wind takes away water vapor, thus ensuring a faster rate of evaporation. Now we can see what is boiling. Boiling is the process in which a liquid substance changes into a gas rapidly on heating. What is the difference between evaporation and boiling? In both processes, the liquid gets converted into gas. Then what is the difference? The process of evaporation occurs at any temperature, but in case of boiling, the process occurs at a particular temperature called boiling point. The temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure is called boiling point of the liquid. Boiling point is a characteristic property of liquids. For example, the boiling point of water is 100 degrees Celsius, which means on heating water up to 100 degrees Celsius, at 100 degrees Celsius, water gets converted into water vapor. The boiling point of ethyl alcohol is 78 degrees Celsius and that of chloroform is 62 degrees Celsius. The boiling point of a solution is always higher than that of the pure liquid. Pressure also affects boiling point. As the pressure increases, the boiling point of the liquid also increases. What is condensation? It is the reverse of boiling. We know in boiling, a liquid gets converted into gaseous state at a particular temperature. Then what happens in condensation? In condensation, the substance in gaseous state changes to liquid state at a particular temperature. Liquefaction is the another term used to refer condensation. In sublimation, a solid gets directly converted into gas on heating and the gas gets directly converted into solid on cooling. The solid substance which undergoes sublimation is called sublime and the solid obtained by cooling the vapors of the solid is called sublimate. Substances like ammonium chloride, iodine, camphor and naphthalene undergo sublimation. Now we can see what are the factors that affect sublimation. Temperature and pressure are the factors which affect sublimation. What is the effect of temperature on sublimation? As the temperature increases, the rate of sublimation also increases. Then, what is the effect of pressure? As the pressure increases, the rate of sublimation decreases. Lower the pressure, higher will be the sublimation. Law of conservation of mass. This law was first formulated by Antonio Laurent Lavoisier in 1789. Law of conservation of mass deals with masses of the reactants and products of a chemical reaction. According to the law of conservation of mass, the total mass of materials present before a chemical reaction remains same after the chemical reaction, which means there is no change in the total mass of reactants and products during a chemical reaction. According to law of conservation of mass, the total mass of reactant is equal to the total mass of products. Suppose in a reaction, the reactant A combined with reactant B to form products C and D. According to the law of conservation of mass, the total mass of reactant, that means the mass of A plus mass of B, is equal to the mass of product, that is mass of C plus mass of D, which means the total mass of reactants is equal to the total mass of products. For example, we can consider the reaction between barium chloride and sodium sulfate. The molecular mass of barium chloride is 208 gram and that of sodium sulfate is 142 gram. Here, barium chloride and sodium sulfate are the reactants and the total mass of reactants is equal to 350 gram. As a result of the reaction between barium chloride and sodium sulfate, barium sulfate and sodium chloride are formed as the products. In case of products, mass of barium sulfate is 233 and that of sodium chloride is 117 as 2 molecules of sodium chloride is forming. Here, the mass of products is 350 gram. The reaction, we can see that the mass of products and the mass of reactants are equal. Thus, the law of conservation of mass is verified. According to law of conservation of mass, there is no change in the mass of the reactant and mass of the product. The total mass of a reaction remains same. Students, thank you for listening my class.